Pranav, welcome to Validated.
Thank you for having me.
Yeah, I'm excited to have you here. You are one of the core contributors and minds behind Shelby. And Shelby is this, as you'll go into details with, this new concept for decentralized storage. It's making, one of the themes of our show is everything is trade-offs. It's just whichever trade-offs you'd like to pick. So Shelby's making a different set of trade-offs than what maybe Arweave or Filecoin or some of the earlier generations of distributed and decentralized storage have made. It's targeting a different market. So would love to get into kind of some of the details of this, but let's kind of start with like high level perspective. Like there's been a lot of blank but decentralized over the years. And sometimes it works, sometimes it doesn't. What about decentralized storage to you was something that said, there's a market here, the current solutions aren't really doing it, and we have something special to go after it? Like, what about, I know you and the rest of the folks from Aptos Labs have been thinking a lot about this. Like, what got you guys thinking this was the problem to solve in Web3?
Yeah, I think it's a great way to start. First and foremost, even before I go into specifics of Shelby and decentralized storage, I think there is one thing has become very clear over the years that nobody's going to use your technology if it's either slower or more expensive just because it's decentralized, right? And just because it's decentralized, that's also not good enough. What is the value addition decentralization brings to your stack, right? That's the bottom line. That's the underlying question. And with Shelby, we observe that the data that is decentralized right now is extremely slow and also expensive to use, right? And having kind of worked at data infrastructure at Meta and having partners at Jump Crypto, who worked on data infrastructure in their HFT systems, we all know that the data kind of is the lifeblood for anything meaningful that you do. You want to process the data, you want to get value out of your business. It's all driven by data nowadays. And so how do we make a decentralized storage system that is high performance, that's cheaper to use, and that has extra features that adds on top of current infrastructure, right? So that was like pretty lofty and ambitious goal that we put in front of us. And apart from being high performance and fast, Shelby kind of brings three very distinct features that anybody, not even in decentralized system, they should be looking forward to using. One, it brings mobility to data. Second, it brings verifiability to data. And third, it brings cost efficiency to data. And so happy to unpack and go into the details.
So as you sort of look at these categories, right? What about the design of this is able to start playing in that market? Because we've seen, I mentioned there's a whole series of decentralized storage protocols that have existed out there, and you can sort of think about them as like, there's always been this question of how do we store stuff in a distributed and decentralized format, and that is largely solved, right? There are a number of protocols now that you can upload something to, whether it is ordinals embedded on Bitcoin, to go for the extreme example. Maybe not for longer. We'll see how the Bitcoin community gets on with that. Or whether it is sort of more classic, like I'd like to upload this thing and pay a certain amount and have it be accessible, for the foreseeable future. That exists today, at least in some capacity. When you get into some of these other types of uses, like the centralized providers have a big market. There's a lot of people using them today. Like, draw me the Venn diagram of areas where there's both a need for faster storage and also decentralization is still kind of something that people are interested in beyond just sort of a talking point value proposition.
Yeah, absolutely. And first, a quick nod to existing technologies. The IPFS, Arweave, and other technologies, they have done a pretty good job at providing, as you mentioned, decentralized storage. You can store the data, it's censorship resistant, it kind of stores multiple copies, data permanence for Arweave's case. And so, kudos to them for starting and kind of, then evolving the stack, and Shelby's now taking it forward, where we want to not just store the data, but retrieve data at scale. And when it comes to decentralization, the distinct advantage that decentralization brings, again, going back to the three categories I mentioned, if your data is decentralized and if you have a global presence, you have a global network, which we'll talk about for sure, and you have a global coordination layer, which is a blockchain, If you have that infrastructure to build storage on, you have a global namespace, which is a very interesting primitive. It is very hard to build in a centralized way. The reason is that you need a globally consistent consensus. You need a globally consistent view of your data, and that all comes free from the underlying kind of coordination layer. So think about your data being in AWS. You go in AWS, you use S3, ask you to use your region, right? Choose your region, and your data kind of gets kind of locked into that regional silo, which was fine because AWS used to be able to kind of provide you all the compute you required, all the processing you required. It was all fitting in one region, just fine. With the AI boom now, though, the GPUs are coming up all over the world. The
Yeah.
GPUs go where there is power efficiency, where there is kind of political will, where there is land available, where this data center build out capacity is available, right? And so now there is this interesting kind of, if you start overlaying current hyperscaler map, and then you put the neo clouds or the new AI data center map, and they don't overlap, right? And so now there is this new need to move data around where GPUs are. So that's one very distinct advantage that global namespace brings. Similarly, there is distinct advantage in data verifiability, where you want to have IP protected data. We all saw the Sea Dance trailers on our X feed, where there is alternative ending, Brad Pitt fighting Tom Cruise, or Jeffrey Epstein case, etc. It's all very funny, but none of that is IP protected, and there is a ton of creativity that you can unlock. And so this is where, if your data has verifiability baked in, you can put in IP protected data, and that works, and that adds a brand new capability which does not exist right now. And the last thing is, when you have decentralized node operations and you have decentralized network, it inherently brings kind of good alignment between people who are operating your network and people who are using the network. And so it brings cost efficiency. So when you have to move large scale data around at high cost efficiency, so again, data mobility, data verifiability, and cost efficiency. All of those are the advantages that we are bringing, and the Venn diagram goes and it all that is specifically now with the need for AI to move data to GPUs, to produce GPU spot instances, to have verifiable generative media. All of that is kind of fits right into the Venn diagram, right at the intersection of this need and this capability.
So let's get into a little bit of the architecture of how this actually works, because with a lot of these things, it's very easy to tell a great story about how a system's going to be super performant, but the
Hmm.
devil's always in the details. So, like, let's start kind of at like a high level architectural overview. Like, what are the components of how a Shelby system works, and how does that differ from some of the distributed file storage systems today?
Yeah. So distributed file storage systems started with I have the spare capacity model. I have a 1 petabyte storage server sitting in my garage, and I would love to join your network and participate in the network. And that is great. You get some cheap capacity, but two major concerns to solve here. Concern number one is that your kind of bandwidth to bring data in and out of network as a node sitting in your garage is pretty constrained. And
Hmm.
we are just talking about fiber connectivity at home just before this, and even in US there is a very kind of patchy coverage. So the nodes generally don't have high connectivity. The second thing is the trust in the node. The node can die anytime. Node can disappear. It can crash. So you have to create multiple copies of your data, right? When you want to use that kind of mode. So again, your network connectivity is a constraint, and your reliability of the node is a constraint. And so you have to design around both of those constraints. Shelby takes a different approach. Shelby is first of all going to identify a ton of data centers across the world with high bandwidth network connectivity, and that connectivity is powered by guess who? Our partners at Double Zero. The name your audience might be quite familiar with. So this is where kind of having Double Zero as a network backbone is absolutely essential to Shelby design. And so now all the data centers which are kind of connected on the double zero network, that is where we can have high storage capacity nodes. Um, Now there are so we are now with this, we are eliminating two constraints. Constraint number one, the low network connectivity, and constraint number two, unreliable nodes.
Yep.
So you can have now more reliable node operations. They are operating as good as any cloud deployment. And then now you don't have to have multiple copies, and you can start actually designing your infrastructure like the big clouds design them, namely using erasure coding scheme as a way to kind of divide your data in the network, and then you bring the data robustness and data availability. So those are kind of the three core pillars. And then on top of that, we have built the decentralization. So Aptos blockchain becomes a coordination layer. So when erasure coding starts splitting your file in many, many chunks, you have to manage every chunk. You have to know which node the chunk is on. You have to make sure the storage node where the chunk is getting paid. You have to make sure the storage node is now being audited. And if a node says I have the data, they better have the data. And we can't just say, we can just trust them. We have to constantly audit them. All of that is coordinated on Aptos in a kind of a global deployment. So we can again coordinate across all of these data centers. The nodes can be all over the world, and we can seamlessly coordinate it on chain. And then comes the layers of incentives. So on incentives, we have to make sure that we are very incentive compatible, right? And Shelby provides read incentives to make it high performance. So the node, uh, the data is split across many nodes, and nodes have incentive to serve the data out as fast as possible and get paid for it. So it's the first ever protocol which has read incentives. So removing the constraints of current systems, adding kind of new system primitives, and then adding new incentive structure is kind of the three core architecture differences we have.
Yeah, how do you think about balancing those different needs? So, like for example, the CDN side and the storage side in the traditional world are kind of thought of as two separate layers. Sometimes, like Amazon
Right.
will sell you a product that does both, but like it's not flattened. In Shelby, it's basically flattened into one system. Correct?
Yes, for the large part. There could still be an extremely viral case where you want to have hundreds of thousands or millions of downloads per day. We could still put some sort of a caching layer on top, which could act like a CDN. But Shelby, because Shelby has two node types. One is what we call the storage nodes. The goal for the storage node is to saturate the available network bandwidth and kind of give as much data as it requires, as much data as can be served. There is another node type called RPC nodes, which will be sitting on the same network. And the RPC nodes will be on demand when the data is requested, would be stitching all of these chunks together and sending it back to you. Now, RPC nodes can be smart and say, hey, look, this particular data set keeps getting asked over and over again. So I'm going to cache it locally, right? And so now there is this two-tier system that largely serves the CDN purpose. And then you can deploy RPC nodes. There could be many different RPC nodes. We can also have custom RPC nodes. They might also want to provide some value-added service on top of your data. So if, for example, there is some RPC nodes, if they are serving some video traffic, they can provide custom transcoding on fly and so the RPC nodes will kind of provide bunch of this functionality that CDNs provide. But at the same time, there is need for hyperlocal CDN and edge CDNs, right? And so that is where
Yep.
some of those requirements may still come from CDN for now.
So, when you kind of look at a system like this, I'm sure there's a lot of you've scoped out a lot of different uses for this system. Like, what are some of the primary? I know you guys are just getting into the testnet phase, but like, who's using the system? Who's signed up to use the system in the future? Like, what does the demand side look like here?
Yeah, and it's been very exciting because some of the demand side, we had not even thought about some of the use cases. And when people hear that, oh, there is a verifiable high performance storage layer, they reach out to us. They're like, how about this? And like, that sounds amazing. In interest of just, I might not share some of the names because we'll be doing a bunch of our partner showcase right after testnet is launched. But I'll be very happy to talk about the test cases. So we have one large a telecom giant. They want to build their ad network with a lot of trust and transparency. If you think about an advertisement space, between publishers, advertisers, and ad network, the incentives are not aligned, and there is routinely fraud, there is routinely data tampering, and just lack of trust overall. I'm a brand. I'm running a massive campaign, and you're telling me I got 100 million impressions, but I'm not seeing the lift. Like, did I get the impressions? Did you target the right cohort? Prove it to me. And that's why there's a bunch of third-party verification, validation, all of that happens. And so, if you think about a scenario where you are able to sign every ad impression with a user key and then batch the data, put it on Shelby, and then the brand can verify, oh, now I see where all the ad was served. Here is a cohort. Here is the verifiable credentials I can see. So it's something that crypto has talked about for a long time. But finally, when you have a high performance verifiable storage, some of these scalable use cases are coming to life. That's number one. Number two, building IP protective generative media. So we are working with a large Hollywood studio. We are building out an AI studio for them. They are going to train models with their IP. And then you can drag and drop different characters. And now there is an on-chain smart contract that says, oh, if you want to use this character, you'll have this is the kind of revenue share agreement. And say, yep, I agree. Great. Now the models have been trained by the studio itself with their IP. Very high quality storylines can be generated. And it is very exciting. And the creators can have a new revenue stream. The studios can have a new revenue stream. And the data on Shelby is now, again, can be checked for compliance. Can be checked for even all the takedown policies can be enforced, and studios can have full control while the data gets monetized and revenue gets shared across multiple parties. So that's number two. Number three, again, this is in the when we are not even conceived this use case, but there is somebody who has access to, or they own bunch of cell towers all over Europe, and they want to build edge inference. And they want to bring a lot of data to their kind of smallish compute capacity that they have, but they have incredible coverage, and they want to bring data to their towers, and they want to use Shelby for that. So these are again like not non-standard, non-crypto native use case. We have a bunch of crypto native use cases as well. We also have data marketplaces. We have a partner who they are really good at capturing wildlife photography, very high quality footage of like polar bears and other wildlife photography. And now there is suddenly so much demand for their content. So they are building a framework on Shelby that agents can discover their data, automatically pay for it, and automatically download it so that they can train it separately. So that's
Yeah. So I want to actually get into that use case a little bit here, because obviously, like anything that touches AI, very buzzy at the moment. But, even setting that aside, like there's been a lot of protocols over the years that have tried to say, in some level, like we believe there's an AI driven future, and we believe that the rights management systems and integrity management systems of today don't work. None of those protocols have actually succeeded in any way. This was the thesis of Story Protocol. This was the thesis of a whole bunch of different systems out there. And I guess one of the things I have always been wondering about was, is this a technical limitation, or is this like a fundamental IP rights problem? Like is it the situation where, like, let's take this like wildlife photographers example, right? Usually what happens when you get into these IP disputes is it's very boutique pricing. In software, we sort of tend to think, okay, well, like if they have 10 gigs of video and I want to consume 8 of them, there's a price per gigabit for that video. And it's like, well, that's not always how it works in the IP space, because there's a lot of like, well, if it's the BBC, maybe I pay them a different amount of money than if it's Coca-Cola that wants to use my polar bears in some advertising campaign that they're doing. So when you look at these markets, like how much is the technology the unlock? How much is it just that enough time has passed and the IP lawyers are thinking about this in different ways? Like, what does that landscape look like?
Yeah, I think from legal side, it's not as long as there is a clean enough way for you to prove that there was a contract, that's generally fine. The challenge I've seen is in two places. One is like what you mentioned, like the boutique pricing, and also discoverability, right? Discoverability is a big challenge. I have this data, it's very valuable, or this is what I think is the price. Now, if you go try to kind of, find an enterprise customer, you have to go through that legal kind of, process that takes months, right, for you to sign a contract. So that kind of timing and that the process time and then the boutique pricing, that all gets slows everything down. The reason why this particular customer wants to build on Shelby is that they see that I can with Shelby there is a programmable pricing you can set, like, hey, it's not just per gigabyte downloaded. It is I have few gigabytes, but they are extremely valuable data, and I want to have probably sell it for $100. Sure, you can just bake it into on-chain logic. So the boutique pricing is for sure, and then there is discoverability. And so this is where it is exciting that in the world where you build for agents, your data discoverability is kind of, you're targeting machines, and then machines are very good at finding and kind of looking up few places, finding the right data, finding the right information. So one of the theses we have now is that what used to get in the way of humans, which was all of this overhead, like you have to look at 10 different places to find where is it available. The second thing is cryptographic proofs that you have to verify and validate. You have to have an account. You have to manage a private key. All of that, these become kind of somewhat accelerants for agents, because agents will have proof, will have cryptographic proof that, okay, this person says they are the owner. This is on chain. Here is the hash of the data packet. Here is the hash of the data packet I have downloaded. I can compare that. Here's my payment. Here's my payment of proof on chain. That's great. I can validate everything. I can put a audit log, and now I have the data, right? And so a lot of these things that generally got in the way of adoption now kind of becomes accelerant in the AI kind of agentic AI space. And coming back to the other use case that we are seeing with the IP that you're asking, like the adoption of IP and why it's not really picked up yet. The thing is, people have been thinking about solving the problem in isolation. Like,
Yeah.
hey, here is a framework where you can register your IP with the smart contract. Okay, great. Then what? What do I do with that IP? How does this IP get used? How does it get monetized? Do you have an anchor customer or two who own the IP, with whom you're working very closely with, and kind of figuring out an end-to-end flow, right? It's not just about having one item in the flow or having like, here's how you can register a smart contract, here's how you can register an IP. What does your end-to-end flow look like, from training the model, to creating the content, to monetizing the content? If you have that whole flow, then you will see the kind of adoption, because the demand is there, the kind of parameters that is driving demands, the new technology improvements are coming there. But thinking about the problem holistically is one missing point. And the second thing is kind of making your data available in a very IP compliant way for agents to act on it is probably the other wave that is coming. So I think Shelby is working on both of them. And that's why we feel much more kind of confident that, yes, we have tried to solve this problem for quite some time.
Yep.
But we have a kind of a more comprehensive solution. So, and then hopefully the adoption.
Nice. So you guys were, I would say, pretty early believers or visionaries in Double Zero. That you sort of looked around this and said at the inception of the project, for Shelby to be successful, it's going to have to go faster than the public internet. And I think there's also some cost modeling in there where Double Zero sort of makes a lot of some of the Shelby economics work better than they would over the public internet. Walk me
Right.
through a little bit of like what that discovery process was like, and how you guys have decided to integrate Double Zero into the system.
Yeah, for sure. And I think I would also kind of, go um, well, as far as saying that having some of those core pieces available allowed us to also be more ambitious, right, with
Mm.
Shelby. And so, like Double Zero having this decentralized network, again, going back to decentralized in and itself. Now you could say, hey, it's decentralized, but it's 5 times as slow than other networks and 5 times as expensive. And we're like, no, thank you very much. We don't need to use that. But hey, it's decentralized, and there are multiple kind of the properties that we get out of double zero. First of all, it's the backbone, it's the high performance network connectivity that Shelby nodes require. We talked about it. Um, but that's not just it, right? You have global coverage. You have the ability to add new network links very rapidly to the network. You have redundancy built into your network traffic, right? You have multi-tenancy to be able to support our burst much more efficiently, right? So all of the things that you require. So if because you are decentralized, you can add new network links much more seamlessly, and you have a nice model of incentive structure that you can incentivize new network link providers to join your network pretty quickly. And so we have talked about in the past that, hey, now we have this demand from this new region is coming up, and your answer is always like, oh, that's exciting, let's talk about it, right? It's never like, oh, no, we can't go there, right? So
Right.
the network, the decentralization provides flexibility, redundancy, better pricing, and just overall kind of better capacity management for Shelby. And as Shelby kind of starts growing, you have, there's models are also quite flexible. And so for us, it was that part of the discovery, that what does Shelby require? Where does Shelby start? Where does it grow? And who can partner with us in this journey and kind of provide us the best technical and economical outcomes for Shelby. So that is where double zero was a no-brainer.
Yeah, and I want to get into a little bit of like what some of those components are, because I think like there's stuff we've obviously gone through in detail here, but I think they're really interesting to tease out around.
Mhm.
One of the things you guys kind of figured out early on is like the billing model of the cloud providers would be very hard to like make a lot of the core Shelby components work. Like, what about that was such a challenge when you guys were first looking at this?
It was super interesting because there is a, if you ask even a technical person, they would say, well, yeah, there is no way you can compete with S3 on pricing. They go way upstream on supply chain. They kind of acquire disk at the cheapest price available. They have their own network, and like that's a generally acceptable. Like I've seen that actually being written down on Twitter by some really
Yeah.
technical people. Like, oh, you can't compete with SEO on pricing, and it's just something that you could, at face value, you might say, well, yeah, that just sounds about right. Until you start unpacking and start thinking from first principles. Like, okay, how much it costs me to acquire hard disk? How much, then what do I need to do? Okay, I need to have network. How much does it cost me to move data around? Then how much does it cost me to serve data out? And then you start putting it together, and then you look at, let's just stick with S3, but any big cloud is applicable, their egress costs, and you're like, whoa, this is incredibly more expensive than all of my calculations combined with adding some, factor on top of it. And so then we realized that the whole goal is to kind of, the big clouds want to discourage you from taking the data out. They just said, oh, anything you want to do with your data, we'll do it for you. Want to process your data? Great, use our services. If you want to analyze your data, use our analytics stack. But they don't want you to take the data out. It becomes kind of, they want to create a moat around the data, and they want to actively discourage. But as we mentioned, and as we talked in the beginning of the conversation, there are kind of competing forces now that want data to be free, that want data to be mobile, that want data to be global. And so this is where when you started unpacking and started talking about the cost structures, and we talked about it. If you put disk, network, and your ISP cost, and some other compute cost that is required, there is a kind of a huge multiplier that all the big clouds are adding, and Shelby would be able to offer same performance, better coverage, somewhat better reliability also, at probably fourth or fifth of the total cost. And so
Wow.
and so this is where kind of, the network plays a very big role, and moving the data around efficiently on a high performance network, cost efficiently, and not just performance efficiently, is a key factor.
And how do the economics work here? Because a lot of the times when we look at sort of compute networks, right? We've stuck with this model of like proof of stake gets you access to compute space. and there's a reward there for securing the state of the network. What does the sort of the token model look like for the Shelby system?
Every node operator. So again, we would provide the whole kind of whole slew of options to node operators, the locations, the data centers where there shall be connectivity. They can acquire nodes with high storage capacity, and they can then participate in the network. It is a proof of stake network in that sense that you have to the more stake you have, the more storage capacity you can participate with. Right, so the Shelby token, you'll have a staking mechanism, and the more stake you can get, also get delegated stake from the token holders, and then you can start having more capacity. The more capacity you have, the more kind of your economic opportunity to make money from just to make money. There are two models where Shelby protocol will generate revenue. One is the storage. So there will be some base price for storing data, similar model to any cloud model. We don't want to have any fancy pricing structures that people have to think a lot about. This is the same as having S3 compatible API. This S3 kind of compatible pricing structure while being much lower in the pricing. So there will be storage and there will be egress. We are also taken away the API cost and some other hidden costs. So there's just two parameters. So think about it from this node operator point of view. If you have the more stake you have, the more data you can store, the more storage revenue you can participate in. And the more storage you have, the more data gets read, the more kind of egress or the read rewards you'll also receive. So I think this is where the token kind of plays an important role in aligning the incentives. Again, if you want to make money as a node operator, you want to make money in the while and get kind of the part of the egress cost. You have to serve data as fast as possible. Otherwise, somebody else could, right? There are multiple operators,
Right.
and so there is economic incentive to make sure that your node is up and running, your node is high performance, and your node is serving data as fast as the network demands. And then we have economic incentive to make sure you are continuously succeeding in your auditing, and there will be as you clear the audits, the escrow account will start kind of dispersing the amount per month. So there is a nice little setup that aligns all the incentives, and all parties are incentivized to make Shelby a successful protocol.
I think one thing you guys have been talking about for a while is the upcoming launch of early access for you guys, getting a test net out in the world. What's going on there? When are people actually going to be able to get their hands on this thing?
So as of this recording, it's now matter of low single digit days. So anytime now.
So it's out by the
Anytime.
time this episode comes out.
Yes, by the time it comes out, the early access should be out. We are targeting developers with our early access programs. We want to make sure, as I mentioned, that it has S3 compatible APIs. We have multiple SDKs. We have Solana SDK. We have Ethereum SDK. We are also going to have Shelby skills. So you can just wipe code Shelby integration. You don't even need to. The incredibly exciting thing is that now everybody is a builder. Everybody with a good idea is a builder. Not, you don't have to necessarily have all the software engineering skills. And so again, Shelby will have skills. Shelby will have its own MCP server. So your agent should be able to build very easily. Shelby will have integrated X402 payment for its data. So you should be able to build data marketplaces. You should be able to build data integration. So all of that is incredibly exciting. So we are inviting developers to join Shelby Discord on shelby.xyz. You have the Discord account, Discord server address. You join there, look at Shelby GitHub, and start building. So that's a goal for early access.
Maybe one last question here. You mentioned there is a multi-party compute server component attached to this. You mentioned there's skills for it. Where do you draw the line between storage and compute? Or do you think it's even worth drawing a line between storage and compute? Shelby's called a storage system. That's the only reason I'm asking.
Yes, this is that's great. Also, one very common the crypto industry is so used to hearing MPC, and there is also MCP. the model context protocol,
Ah,
right?
sorry. Yes.
So we also have an encryption service, which will be MPC at some point for encrypting your data, and we have MCP, the model context protocol, and Shelby tools and resources will be available for you to build seamlessly with Shelby. The compute versus data is or that separation is extremely it's a very interesting way to think about it from Shelby point of view. And the reason why I say is there are two types of compute, right, that potentially will be. One is verifiable compute that people would want, like, hey, it's a decentralized protocol. I want verifiable computing. And there is a lot of progress is being made, especially in trusted execution environment, where your memory will be loaded with a certain context that is authorized by a certain user, and your memory space is kind of very well protected. And so going back to our conversation with RPC nodes, when I said RPC can be can provide a lot of value added services, that requires compute right there. There could be somebody who wants to participate in the network and offer up a service as just a trusted vendor and says, hey, look, I'll take data from Shelby. The data is verifiable. On top of that, I'll provide some simple compute, some basic functionality, may or may not run in T, but I have some GPUs and I can just give you some edge inference, etc. So this is where we would love to see what developers are thinking if they want to build something custom and say, hey, I would love to add some compute on top of Shelby. We would be very open to seeing some ideas around custom RPC nodes that can be deployed as part of the Shelby network. There are some conversations already that are going on there, and as part of early access, we are excited to see what developers will build there.
Well, Pranav, thank you for joining us today on Validated and giving us an overview of Shelby.
Thank you very much for having me. It's always so much fun to talk to you.